Welcome to the Math Record. Today we'll be covering the CCML Algebra 1 Contest 1 2016-2017 Division A. Okay, let's just get started. Question 1. Evaluate 4 minus negative 3 times parentheses 4 plus 3 parentheses. So basically, let's just do order operations. So it's 4 minus 3 times, that's 7. So that's negative 21. 4 minus 21 equals negative 17. Basically, that's simple. It's the first question. So the answer is negative 17. A, 2a plus b over a minus b. Determine the value of 4 of b of negative 2. 3 of negative 2. So that would make 6, and that will put negative 2 minus 2 over 3 minus 2, so that minus negative 2, which is 5. So this will get 4 over 5. So the first part of it is 4 over 5. So 4 over 4 over 5, that makes 8 plus 4 over 5 all over a, which is 8. Which is 4 minus 4 over 5. That gets, that's 40. That's 44 over 5. All over, what's that, 20? So that's 16 over 5. So simplifying it, it would get us 22, actually divide by 4, will be 11 over 4, which would be our answer, 11 over 4. Okay. Question 2. Question 3. Robert hiked on a lakeshore path towards Indiana for 10 and 2/7 kilometers for 1 and 7/9 mile for hours. On his return trip, he hiked at a rate of 4 over 22.35 kilometers per hour. What was Robert's average speed for the entire trip? So we had to look for the total distance over the time. So basically, we have the total distance, the distance for half the way because he's going to Indiana, and then he from Lakeshore path to Indiana, and then Indiana back to Lakeshore path. So he's going twice this distance. So it's 2 times 10 and 2/7 all over whatever his time. For his first time is already 1 and 7/9 plus he biked at a rate of 422 over 35, which is his kilometers per hour. So on the return trip, he took 2 over 2/7 because that's the total amount of miles, and his hours is 4 divided by 4 over 22 over 35. I'd rather not do this by hand since this is already calculated. The first contest. You most likely would just want to use your calculator to do all this math, so then you know you're not going to make like some stupid math mistake. So 2 times 10 and so that's like 72. 72 divided by 7 times 2, that would be our numerator, and that would be 16 divided by 9, and that will be 72 divided by 7, and that number is divided by 35 times 4 plus 32. Put that in parentheses. Divided by 35. And then you add those two numbers together. So the bottom part is 4. And the upper part is 144 over 7. So it will be 144 over 7 over 4. So we just put a 4 in the bottom. So crossing out the 4. So 144 divided by 4. is 36. The answer is 36 over 7, which is really that basic. So you just put the total distance, so the distance over the time, basically. So the time of the time to go towards Indiana, and the time it goes return back, and then the total distance. Okay. Question 4. Determine 1.042. The 42 is repeating as a common fraction. What I would do is that I will set the number x a variable, so x is equal to 1.042, which is repeating. And now I want to like multiply by a certain amount just so this 42 would stay the same. So if I want let's say 1, 2, 3, right? You want to go 3 over, so you gotta multiply by 1,000. So it's gonna move 3 decimal places. So it's gonna go to 42. Actually, you want to multiply by 10,000. It's gonna move to 4 decimal places. So it's gonna be 0, 4, 2, and then another 4. So it's gonna be 1, 0, 4, 2, and another 4. And since it repeats at like 4, 2 repeating, it goes like this, and then like it's gonna repeat later on, and it keeps going in that order. See? So now at the same decimal places, it has the same decimal places, right? So if we subtract this by this, you get 9,999x is equal to what's 10424 minus 1, which is 10423. And then 2 minus 0 is 2. And then 0.42 repeating minus 0.42 repeating is just 0. So this is just the remaining. So just divide by that number from both sides. 9999. And you'll get the answer. Just use your calculator for this. So 10423 divided by 2. 0.2 divided by 1. 9999. And then you get 172 over 165 using your calculator. So it's basically that simple. One of the basic questions in CCML and algebra, repeating decimals, which is what I refer to them as. Evaluate 8 plus, it might be really hard to see, so I'll write it out. 8 plus 10 over 3 minus 3 over 2, 3 to the power of 2 times 7 over 3 divided by 1/4 minus 2. Since you're giving a calculator, just put this in your calculator. There's just basically no point. So 7 divided by 3 divided by 1/4 minus 2 multiplied by 9 multiplied by -1 because there's a negative of that entire side. And then you add that to 10 divided by 3. Then you add 8, which gets you 70 over 3. I don't know why this question is on the CCML. You basically just plug everything in and you solve it. So that was question 5. Pretty easy so far. The first few 5 questions were pretty simple. Out of the hardest, it might be either 4 or 3. Question 6. In an English class, 16 students like Harry Potter, 20 like Lord of the Rings, and 14 like the Chronicles of Narnia, and 3 like all 3 series. If the class contains 33 students, how many students like exactly 3 series? So we're going to have to make a Venn diagram, and we have to make 3 circles because there are 3 categories. So we have Harry Potter, we have Lord of the Rings, and we have Narnia. So what can we already get for just one section? We know 3 like all series, and we're gonna label this A, B, and C. Because we want only these sections right here. We don't want A, B, C, or the 3. We just need to only add those. So what we need to find is A, B, and C, or all 3 of them together. So we have 20, which 16 that likes Harry Potter. So that is 13 minus A minus B in this circle. And in Lord of the Rings, we have 20. So that would be 17 minus A minus C, because it has to be right here. And 14 like the Chronicles of Narnia. So that would be 11 minus B minus C. And all these sections had to add up to 33. So this plus this plus this plus this plus this plus this plus this. So if we do the sections, these numbers cancel out with this number because you add them. This will cancel out with this one. So it would just be the 13 plus the 3 plus the 17 plus the 11. And then minus A minus B minus C equals to 33. So we have 40. The numbers add up to 44 minus A minus B minus C is equal to 33. That's what it's saying. So A plus B plus C has equal to 11. So A, B, and C has to equal to 11. That's what they equal to. So if A plus B plus C is equal to 11 and you only want this section, these three sections, then you just have to find, you just add them together. So 3 plus the 11 is 14, and you have 33. So 33 minus the 14 is equal to 19. So 19 is the answer. Because the ones that only like one series. Basically that simple. Question 7. How many positive integer divisors does 504 have? There's a pretty neat trick about this. First, we have to find the prime factorization. So if I see it even, I'm just going to divide by 2. So it's 25, 2. And then divide by 2 again. That's 125, 126, I think. Yep. Yeah, 126. And then divide by 2 again. That gets 63. And this one is just 9 times 7, which is just 3 squared times 7 times 7. So this overall factors out as 2 to the 3 times 3 to 3 to the 2 times 7, which has to equal 504. So we would check that to see if that's true using your calculator. Or you could use your calculator to factor out. There's some calculators could do it, which is true. So what you do is that you add 1 to every single exponent. So you get a 4, you get a 3, and you get a 2. And then you just multiply them. So you get 12 and 24. So the answer is just 24. That's basically just how you do it. That's all you had to do. It works for every single case, all the time. To find all positive integers, divisors. This is true because let me give you a smaller case. Let's say you have like something like 9, right? No, let's do something like that's actually like 6, right? 6 is just 3 and 2. So you have 3 to 1 times 2 to 1. So it's just 2 times 2, which is equal to 4. And there's 4 divisors, which is true, which 1, 2, 3, and 6. And it's true because like it's just basically based on permutations. Because you could either have 0 3s or 1 3, 0 2s or 1 2. So in combination, it would just be like 3 0 times 2 0, 3 1 times 2 1, 2 1, and then sorry, that's 3 0 times 2 1, and that's 3 1 times 2 0, and that's 3 1 times 2 1. This gets 1, this gets 2, 2, this one gets 3, and that gets 6. You see how that gets out like the factors? And you just have to find all the possible factors that you put this. And then you just multiply it. So that's how you just do with combinations. And that's how you work with question 7. 8, determine the greatest common factor of 840. So you could use your calculator to do this, but if you want to do this by hand, it's basically just 840. Let's say just say 4 because I know it's divisible by that. That's 210. So that's a 3. There's a 3 here, and there's a 7 here, and there's a 10 here. So I'm not gonna factor this out any further because I feel like the numbers are small enough. So we have 1848. Divide this by, is this divisible by 4? 1848 divided by 4. It is. So it's 462. And divide that by 2. 462 divided by 2 is 231. Sorry. 231. And what does 231 factor out to? Which is a 3 times a 7 times a 11. So there's a 4 here. This could turn into a 2 and a 5. So we have a 2 here and a 2 here. We have a 3, we have a 3, and we have a 7, and we have a 7. So it's a 4, 2, 3, and a 7. So multiply those together. 2 times 3 times 4 times 7. It's equal to 168. That's the answer. Basically that simple. Or you could just use your calculator, and your calculator has like probably a factor section, or you could just download a program for that. That works too. Number 9. Given the sequence 21, 16.5, 12, 7.5, what is the 301st number in this sequence? So let's find out what like this sequence is. So that's 21, that's 16.5, that's 12, and that's 7.5. The first process I would think is either arithmetic, and then second I would think is geometric. So first, let's just say it's arithmetic. So that's minus 4.5. That's also minus 4.5, and that's minus 4.5. Okay, so this is actually arithmetic. So it's gonna be negative 4.5, and then x minus 1, because the first number minus that plus the 21, because that's the first number. So the first number is 21. The second number is 16.5, and this equation would just get that number. So finding the 301st number, you just plug x is equal to 301. So use your calculator. So 301 minus 1 is 300. 300 times negative 4.5, and then add 21, you get negative 1329, which is the answer. Which is basically just that simple. It's just a simple arithmetic progression question. Question 10, we're halfway through right now. In an equilateral triangle if an equilateral triangle and a square has the same perimeter, what is the ratio of the triangle's area to the square's area? So let's just draw the shape out. So we have a triangle, equilateral triangle, and a square. They have the same perimeter. Let's just label this as x. So this x, and x. So the perimeter is 3x. So since it's a square, I have to split that to 4. So 3x divided by 4 is 3/4 x. Sorry. X. And each side of here is 3/4 x. Okay, which is a square. So what is the ratio of the triangle's area to the square's area? The area of an equilateral triangle is calculated using a side. If its side length is x, it's gotta be x squared square root 3 divided by square root 3 divided by 4, which is true because like I could draw the picture out for you. So if it's an equilateral triangle, right, it's 60 degrees, and this is the 60 degrees, right? So this is 60. So if this is x, then the 30 degrees, the side length opposite of the 30 degrees is halfway through, so that's x over 2. And since this is x over 2, you could use the Pythagorean theorem, and that gets you x square root 3. X square root 3 divided by 2. Which is true. So these are the 3 side lengths, and that's a right angle. So if you find the area, it's just this x over 2 times x squared over 2 divided by 2. But then since there's this other side of the triangle, because you only calculate this area, then you have to multiply by 2. So dividing by 2, multiply by 2 kind of cancel each other out. So you only get x squared square root 3 over 4. That's basically how I know it's the area. You can also prove it like that if you want, but if you just memorize that if the side length is let's say variable x, then the area is just x squared square root 3 divided by 4. And the area of the square is, since each side length is 3/4 x, just square it. So that's 9 over 16 x squared. So what is the ratio of the triangle's area to the square's area? So this number divided by this number is just square root 3 of 4 divided by 9 over 16. So dividing by a fraction is just multiplying the reciprocal. So the 4 cancel out with the 4 here. So that's 4. So that would be 4 square root 3 over 9. And that's how you get the answer. Kind of interesting question, but they overuse CCML overuses the equilateral triangle question area a lot. So just try to memorize it and you'll basically know. So it's, to reiterate, it's x squared times square root 3 over 4 if the side length is x. A $5,000 investment was made in January. In February, the investment gained 25% of its value. In March, the investment lost 25% of its value. In April, the investment gained 25% of its value. If the investment had lost 25% of its value in May, what was the percent change in the investment's value from the initial amount? So basically, the first number is irrelevant because it's talking about percentage. So what you have to know is that in February, it increased by the value gained 25% of its value. So you multiply the 5,000 by 1.25. So this is just an exponential question. So it's really easy. So the next number is in March, which lost 25%. So you multiply by 0.75. And then in April, it gained 25% of its value. So it multiplies by 1.25 again by the previous amount. So it's 5,000 times this times 1.25, and then that amount multiplies by this, and then that amount multiplies by that. So that's in April, and if the investment lost 25% of its value in May, so it's multiplied by 0.75 again. What was the percentage from the initial amount? So using calculator, you really don't want to like multiply by 1,000. There's basically no point. You're gonna be adding extra steps. So it's just 1.25 times 0.75 times 1.25 times 0.75, and you get 0.87890625, right? So that's the amount. So what was the percent change? So the percent change is gonna be negative. So you're gonna, because it's less than 1. It's less than 1. If it's greater than 1, it's gonna be increase. So you're gonna pay something percent decrease. So it's gonna be use 1 subtracted by that number, and it says round to the nearest tenth of a percent. So whatever 1 minus that number, you get like 0.1210935 multiplied by 100, and you get a nearest tenth of a percent is 12.1%. So it's a 12.1% decrease. I'm not gonna write the entire thing because actually I'm gonna try. Yeah, I have room. Okay, so it's a decrease. It's a 12.1% decrease. It's basically that simple. Okay. That's question 11. Question 12. The statement n line k means that n is a divisor of k. Okay. For example, 5 line 20 means that 5 is a divisor of 20. What's the largest prime number such that n is the line of 275? So n line 2756. So we got to factor line 2756. You probably just want to use your calculator. I really don't want to do this right now. So 2756, you get 2 to the 2 times 13 times 53. So the largest prime is just 53. So the answer is just 53. Since this like contest 1, just know how to use your calculator. Like the calculator will save you so much time. Okay, question 13. A square has 2 diagonals. A pentagon has 5 diagonals, and a hexagon has 9 diagonals. If a polygon has 33 diagonals, how many sides does it have? So we gotta think about it. A square has 4 sides, and it has 2 diagonals. And a pentagon has 5 sides, and it has 5 diagonals. And a hexagon has 6 sides, and it has 9 diagonals. So basically, what's the increase? So this is a 3, and this is a 4. Okay, so basically, so if we have a heptagon, that's which is 7 sides, I'm imagining this one would be a 5. This is increasing by 1, so this would be 14. So which might be true. Let me check. So, yeah, it is. So, there is a really good equation to solve for this. What you can make a regression out of this if you have the points. So it's just 4, 2, 5, 5, 6, 4, and 7, 14. And you can just make a regression and then plug in, and you get a equation, and you plug in x is equal to you find one y is equal to 35. You also do that. But there is a good equation for this to find the diagonals of a polygon, which is calculated as if the side length is x, then it's x times x minus 3 divided by 2 is the amount of diagonals. So you have 35 diagonals, right? So you have x squared minus 3x. So 2 times 35 is 70. So this side is 70. So you minus 70 equals 0. So 70 could be made into 10 and 7. So x minus 10 and x plus 7. So that's x squared, 7, negative 10, so negative 3x, perfect, negative 70. So x is equal to 10, because you can't have negative sides. Question 14. A rectangular prism has a volume of 36 centimeters cubed. If the length of the edges must be natural numbers, how many different different edge length sums, the sum of all 12 edges, are possible? Since it's a natural numbers, the length, width, and height has to be like 1, 2, 3, 4, 5, or something like that. No, so the volume is 36. So the only way you could get to 36 is 2 to 2 times 3 times 2. So that's 9, and that's 4. So 4 times 9 is 36. So the only ways you could write is 2 times 2 times 3 times 2. So we have that. So what are the factors of this in like pairs? So basically that would be 136, 218. Sorry, I need to get myself more room. 218, 312, and 4, 9, and 6, 6 as they multiply together. So this could be split into because you can't split the 1, you only can split the 36, so that's 136. So this one's basically the same thing, 218, 312, 4, 9, and 6, 6. That's 1. That's 1. That's 1. That's 1. Right? And then we have 218. You can't split the 2 because you already got the 1 here. So basically we're gonna split the 18, so that's gonna be a 2. It's gonna be we can't split it to 118 because we already got all the probability with ones. So it's gonna be 2, 9, 2, 3, and 6. So basically that's all. We can't go anything higher. So 312, we got 3. You can't get 1, 2, or 1 or 2. So you're gonna have to get because we already got the 1s and 2s here. So you gotta get 3s and above. So that's 3 and 4, which stops there. So 4, 4 can only get 3s, double 3s. So 4 could also be split into 2, 2, but that's not gonna work either because that's 2, 2, 9. So 6, the 6 can only, like, if you only do one side, you don't have to do the other side. So you have a 2, 3, and 6. I mean, there's nothing else you could do, like 1, 6, 6, right? But you can see it right here, 2, 3, 6, which is already used right here. 2, 2, 9, which is already used right here. 4, 4, 6. So all these combinations are out because they're already like multiples, basically. So you have 1, 2, 3, 4, 2, 4, 5, 6, 7, 8. So those are like the only combinations that like kind of makes sense. So let's see if they have like different sums. So this one adds up to 38. That adds up to 21. That adds up to 15, 16. So that's 16. That adds up to 13, 14. That's 14. That's up to 12. That's 13. That's up to 4. That's also 13. And this is 8, and that's 11. And that's 6, and that's 10. 13 is used twice, so you cancel that one out. So how many possible are there? There's 1, 2, 3, 4, 5, 6, 7. So the answer is 7. Because there's 7 possible. So that's what you do for this type of question. You kind of just like list them out. An interesting question, but it might take a while. But if you list them out, it shouldn't be that much harder. Okay, question 15. What is the largest positive 4-digit integer that's divisible by 2, 3, 4, 5, 6, 7, 8, 9, and 10? So let's write that down. What's the largest possible 4-digit integer? So it's a 2, a 3, a 4, a 5, a 6, a 7, a 8, a 9, and a 10. Okay, so basically, if it's divisible by 10, it can't be divisible. It cannot be like you already got 5 and 2, so you don't have to do that. If it's divisible by 9, it has to be divisible by 3, so you don't have to do that. If it's divisible by 8, it doesn't have to be divisible by 4. That's basically the point. So you kind of cancel all these out. So you have already these numbers. So it has to just be divisible by 9. And it has to be divisible by because you basically just look at the factors, because we need a 2 in there, because it has to be 8, right? We need 3 2s. And how many 3s we need? We need 2 3s because of the double 9s. We need 1 5, and we need 1 7. And the next prime is 11, so this is all we need. We need 3 2s, 2 3s, a 5, and a 7. So what is the largest positive 4-digit that is divisible by this? So basically, this is all you need. So you need 2. So this is the minimum amount you need. So this is 8 times 9 times 5 times 7 times some kind of integer that is less than like 9999, less than or equal to it. Because you can't have 1,000. So what you're gonna have, you should use calculator. 9999 divided by 9 divided by 8 divided by 5 and divided by 7. So that number is 3.967 something, but it has to be less than or equal to it. So, but it has to be an integer. So the answer, so x has to be equal to 3. It has to be, because that's the highest integer you could go up to. So it's 8 times 9 times 5 times 7 times 3. Which gets you 7560, which is the answer. 7560 for number 15. Pretty easy. So it's basically like one of those like kind of like looking for factors. A lot of these questions have to look for factors. What's the units digit number 16? What's the units digits of 2017 raised to power of 2016? Okay, so if it's talking about the units digit, we only care about the units digit of the base. So the units digit of the base is 7. So we're gonna have to think about it. If 1 is raised to a power, if 7 is raised to a power of 1, it's gonna equal 7. If 7 is raised to a power of 2, it's gonna equal to 49. So the end digit is 9. If 7 is raised to a power of 3, it will be 49 times 3. 49 times 7, which is ending in 3. And 7 raised to the power of 4 is 2401, which ends in 1. So 7 to the 5 ends in power of 7. And it kind of just keep repeating like that. So it goes in a cycle of 4. So the one that really matters are this. So it goes by 7, 9, 3, 1. Every single 4 will rotate the cycle. Because you don't care about the other values, but they're gonna just get higher and they're not gonna add up to the 1. So the unit digit is the only one that matters. So we have 2016, right? 2016, what is that? 2016 divided by 4, because it runs at every single multiple of 4. Since 2016 is divisible by 4, that means it has to end at the last combination. So it has to end at this. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You see how all these numbers are divisible by 4? Yeah, so 2016 is divisible by 4, so it has to end at 1. So that's the answer. The answer is just 1. So that's a really big... These questions will recur in a CCML a lot, the units digit. What is the least common multiple of... But to go back to the units digit question, like basically you just look for the pattern. Just always do like the exact process. Like if it's like 2012, then just get 2 to 1, 2 to 2, 2 to 3, and 2 to 4. It usually repeats every single 4 cycle, except like a few numbers that don't. Like 5 don't repeat because it's just 5. Anything raised to the power of 5 is just gonna end in 5, like, or 6, or like 9, because it's like 9 and then 81 and then like 729, so it's 9191. But all the other ones like kind of go well. Or also 1. 1 raised to any single power is just 1. 17. What is the least common multiple of 24, 35, and 50? So if you don't know how to do it, it's pretty basic. So it's 24, 35, and 50. So factor it. A lot of these questions had to factor. 2 times 2 times 2 times 3. This one is 5 times 7. And this one is 2 times 5 times 5. So you need all these numbers. So you need a 2 times a 2 times a 2 times a 3. You need a 5, and you need a 7. You already got the 2. You already got the 5 right here, and you need another 5. So from this set, it has all these possible numbers. So it's just going to be 2 times 2 times 2 times 3 times 5 times 7 times 5, which gets 4,200 as the least common multiple, which is also referred to as the LCM. Because the LCM is, if you divide the LCM by any of these numbers, so 4,200 divided by 24, 35, or 50, it's got to get an integer. That's what it means. Question 18. What's the largest 7-digit positive multiple of 11 that contains only 3s and 4s? Okay, so the thing that stands out to me is that it's a positive multiple of 11. So let's just draw the number first. 1, 2, 3, 4, 5, 6, 7. If it's a positive multiple of 11, what I know about the rule for 11 is that if you subtract the numbers together, so let's say 1, 2, 3, 1, 2, 3, 4, 5, 6, and 7. Sorry about that. If it's the first number minus the second number plus the third number minus the fourth number plus the fifth number minus the sixth number plus the seventh number must be equal to each other. So the first, the third plus the fifth plus the seventh must equal the 2 plus the 4 plus the 2 plus the fourth number plus the sixth number. So right off the bat, the highest number we can make if it's only made of 3 or 4 is that if 1 is equal to 4. So if 1 is equal to 4, that means this number has to be 4 higher than these numbers. So even we use the lowest numbers, which is 3, 3, and 3, and these numbers are 4, 4, and 4, right? These will only be 1 higher than, only be 3 higher. And this one will be one, this entire side will be the 1 less. So 1 cannot equal to 4. 1 has to equal 3. If 1 is equal to 3, then everything else has to be 3, and this has to be 4, as I shown in that example. Because you can't have any other numbers. If you go like smaller numbers, then it's gonna make not 3s or 4s. Because the only ways because if you add this number to like a 4, then this thing has to go higher also. But it can't, because it's only 3 and 4, because those are the numbers it's limited to. So the only number that you can make is this. So based on that number, you had to have a 3, 4, 3, 4, 3, 4, and a 3. So basically, this is the answer. Because you can't like do anything like about that. So this is what you're limited to, because you only made out 3 and 4s. So that's the answer, which is what is that? Which is 3,334,334. 3,343,343. So that's the answer for 18. Question 19. Evaluate square root 6, square root 48, square root 6, square root 48, repeating. So, let's just have this, x is equal to that number. So square root 68 over square root 48, all over square root 6, square root 48, etc., right? So basically, we need to find, this is what I call as a repeating radical. So what you do is that you substitute x back into the variable somehow. So you have a 6 and you have a 48. So those are the ones that are repeating. So you have already a square root 6, so you can already put x right here. because that's the same thing. If you substitute this value back into there, it's just repeating more. So what you do is you already have the square root, so square root again. X squared is equal to, divide by 6, so that's 1/6, is equal to square root 48x. So square it again, so that's 1 over 36. X to the 4th is equal to 48x. So we had to subtract that, and you have to subtract the 48 and kind of take out the x. So what you're gonna do is, sorry, 1 over 36x, what makes x cubed minus 48 times 36, which is equal to 171, sorry, which is equal to 17, equal to 1728 as the remainder. So now we have x is equal to 0, or x is equal to the cube root of 1728. The cube root of 1728 is 12. So the radical is equal to 12. So that's the answer. Basically, anything you see with repeatings, always use variables. Like the question with 4, same thing with 12, 19. They both use repeatings. Question 20. How many of the first 400 positive integers are divisible by 3, 7, or 8? So there's actually several steps in this process. So the first 400 positive integer. So positive integer would be from 1 to 400, because 0 is not a positive integer. It's not positive or negative. So so it's 1 to 400. So you gotta think about it. You have 400 as the highest number. You divide it by 3. And then you have 400 divided by 7. And you have 400 divided by 8. Because every single third number, it's an integer. Every single seventh number is an integer. And every single eighth number is an integer. So, but anything remaining over, you just don't care. So 400 divided by 3 is 133. 400 divided by 7 is 57. So you don't care about the decimals because we don't want the remaining over. And 400 divided by 8 is 50. So basically, these are all the numbers that are either 3, 7, or 5. But since some of them overlap, because like let's say the 21st, but you're counting it twice, so you have to look for multiples of those. So 400, so 3 times 7 is 21, and 3 times 8 is 24, and 7 times 8 is 56. So the numbers for those is 400 divided by 21 is 19. 400 divided by 24 is 16. And 400 divided by 56 is 7. Okay? So now you kind of got all the ones that are pairs. So, but some of them are like 3, 7, and 8. So you got to remember those. So 3 times 7 times 8 is 168. So we had to have a 400 divided by 168. So 400 divided by 168 is 2. So these are all the ones, including the pairs. So subtracting the pairs out, you take those out. But some of the pairs also kind of combine together because there's 3 of them. So you have to add all these, subtract all these, and add the triple one. So you add all the singulars, subtract all the pairs, and add back the triple. So you have a 133 plus a 57 plus a 50 minus a 19 minus a 16 minus a 7 and plus a 2. And your answer is 200. And that's basically how you do it. Because basically what this so the answer is 200. So basically what this process is doing is that, let's say you're looking for um divisible by 2, divisible by 3, and divisible by 5, right? So you have something like this. So you have x no, divisible by 2. So we x is going to be like the number. So x 0 0 0. You have 3, and we have the 5, right? So every single 2, every single 3, every single 5. So we're going to have 1, 2, etc. Actually, let's just write actually 10 of them. 2, okay? Oops, sorry. I'm missing some. X0, X0, 1, 2, 3, 1, 2, 3, 4, and 5. Okay, so 0, 0, X, 0, 0, X, 0, 0, X, and 0. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So what this is doing is that the first process dividing by a 3, 7, and 5 is like if it's dividing by 2, 3, and 5, what it's doing is that it gets all the numbers for this one, for the first one, and then gets all the second one for the 3 one, it gets all the numbers for this for the fifth one, right? So that's the first process. It gets us those 3 numbers. So you add those numbers together. But then those numbers have overlap, like right here and right here, right? So you see those, so you have to subtract those out. So you get the pairs for this, get the pairs for 2 3s, 2 5s, and 3 5s, and you subtract those out. Then those numbers like are, let's say, D, E, and F. So you minus all those. But then some of pairs have sometimes like X, 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 right? Which makes sense because like you have something like 30. 30 is divisible by 2, 3, and 5, but you subtracted those out because you subtracted this out like twice. Because let's say it's a multiple of 6, right? And it's also a multiple of 15. So you subtracted it out during the 6 multiple, and you subtract it out during the 15 multiple. But you're only supposed to subtract it once. So what you're supposed to do now is that you have to add them back in. So you multiply those together, and you get 30, and you kind of like add that number back in. So that's what you're doing. First process, the second process, third process. So that's how you get that 200. Anyways, that completes the CCML Algebra 1 Contest 1 2016-2017 Division A. Thanks for watching, and I'll see you at the next math record.